Hi, everybody. I'm so sorry. I accidentally skipped ahead in the agenda there. That video obviously was from our other implementation partner, Lawrence Berkeley National Lab. That was our virtual tour of Berkeley Lab. And I would also like to recognize their amazing partnership in this opportunity. We really have created a new public-private partnership structure, and it is an incredible structure. And I hope that it is replicated regionally, and that we can then potentially have a national cohort of regional or a national collaboration of regional partnerships like this, public-private partnerships with the labs. There's 17 national labs throughout the country. And I just want to say that we really value this partnership with Berkeley Lab and with the University of California Office of the President. Now, we are at the right stage in the agenda where we will be bringing up our renewable generation panel. And Maite, I'm sorry for jumping ahead. I would like to invite you to join me up on stage. And if you wouldn't mind introducing yourself and providing a few framing remarks, and then introducing our panelists.
Thanks, Tenley, and no worries. This is what comes with doing things virtually, so the joy in it. So as Tenley mentioned, I'm Maite Sanchez, and I am the Director of Energy for the Los Angeles Clean Tech Incubator. So at LACY, our mission is to create an inclusive green economy through unlocking innovation, transforming markets, and enhancing our communities. For today's panel, I have the pleasure of speaking to companies who are focused on renewable generation. Before we actually get started with the discussion, you're actually going to hear from the entrepreneurs themselves, and they're actually going to have the opportunity to introduce themselves. So with that, I'll ask Benjamin to come on stage and tell us a little bit more about Tectonicus.
Hi, can you hear me?
Perfect.
All right. Hi, I'm Ben Leslie with Tectonicus Constructs. We're a research, architecture, and engineering firm with employees in California, Arizona, and Massachusetts. We aim to cover and power canals with solar energy. Moving water across the West is the largest user of electricity. And thermoelectric power production is the largest industrial user of water. We aim to greatly reduce this wasteful cycle of water and power. And our net benefits include huge reduction in land.
Now, we are at the right stage in the agenda where we will be bringing up our renewable generation panel. And Maite, I'm sorry for jumping ahead. I would like to invite you to join me up on stage. And if you wouldn't mind introducing yourself and providing a few framing remarks, and then introducing our panelists.
Thanks, Tenley, and no worries. This is what comes with doing things virtually, so the joy in it. So as Tenley mentioned, I'm Maite Sanchez, and I am the Director of Energy for the Los Angeles Clean Tech Incubator. So at LACY, our mission is to create an inclusive green economy through unlocking innovation, transforming markets, and enhancing our communities. For today's panel, I have the pleasure of speaking to companies who are focused on renewable generation. Before we actually get started with the discussion, you're actually going to hear from the entrepreneurs themselves, and they're actually going to have the opportunity to introduce themselves. So with that, I'll ask Benjamin to come on stage and tell us a little bit more about Tectonicus.
Hi, can you hear me?
Perfect.
All right. Hi, I'm Ben Leslie with Tectonicus Constructs. We're a research, architecture, and engineering firm with employees in California, Arizona, and Massachusetts. We aim to cover and power canals with solar energy. Moving water across the West is the largest user of electricity. And thermoelectric power production is the largest industrial user of water. We aim to greatly reduce this wasteful cycle of water and power. And our net benefits include huge reduction in land use compared to utility scale solar, reduction in thermoelectric water use, reduction in evaporation, algae growth, and a power boost from solar panels that are operating cooler over water. Currently, we're in the SBIR phase 2 prototype test, and we're working with UC Merced and the University of Arizona and George Cairo Engineering.
Hello, you can hear me? My name is Björn Paulsen. I'm representing Paulsen Inc., and we are an optical sensor company. We develop optical sensors for the most, I think, exciting application is for high temperature geothermal energy extraction. Our sensor, we have tested them to 320 Celsius. We have plans and designs for going up to 700 degrees Celsius, over 1,000 degrees Fahrenheit, to monitor the subsurface, both in terms of characterization of the subsurface, as well as monitoring the fluid flow in the subsurface. And you can see on the top right is our facility, 12,000 square foot facility. We moved into this facility a number of years ago. We have developed it since, from being just a concrete shell to being a manufacturing facility for high resolution optical sensors. And the picture below that is from our optical clean room, 1,000 rated clean room, where we make our sensors. We write our own fiber Bragg ratings. And we found that in order to develop sensors and build sensors, to deploy them, we had to develop our own manufacturing capability. So that's now operational. Below that, you can see one of our surveys for working with Battelle in Michigan, monitoring the carbon dioxide injection into a carbonate reef. And we found that we actually can hear the fluid flow of the CO2. And of course, once we can hear the fluid flow of CO2, or the flow of CO2, we can also do the same thing with natural gas, as well as hydrogen, and as well as the fluids in the geothermal reservoirs. And together, underground gas storage and plus hydrogen, carbon capture and sequestration, and enhanced geothermal, today is a $500 billion market. It is expected to grow in 5 years to be $1 trillion market. So we're addressing something to help to generate clean energy within the United States. And I'm particularly interested into the tremendous potential of the geothermal energy we have, particularly in California, but also in the nearby states. So we're looking forward to work with Cal Test Bed, the UC Riverside, to test our sensors and validate the sensors' performance. Thank you so much.
Hello, can you hear me? I assume so. My name is Mark Anderson. I'm the founder and CEO of Icarus RT. And earlier today, just a few moments ago, actually, Jigger was talking about the performance or efficiency of PV panels, which was at about 13% 30 years ago, I think he said, which I often use that in my talks. And I'm a little more generous than him. He said today they're about 19%, and I'll usually say 20. But the problem is that panels heat up, and as they heat up, their performance drops every single day even further. So if they're at 20% today, on a warm day in Southern California, they may be producing only about 15 or 16%, and that's pretty much an everyday occurrence. So we just set out to cool panels and see what we could do with the heat that we were extracting. And we've proven our ability to cool panels significantly, enough to improve the output of panels an additional 12 to 18% of that 20%, or that between that 16% and 20%. And what was more important, though, we discovered that of all of that waste heat that we're pulling away from the panel, that's our heat extractor shown at the bottom. We use that to snap onto the back of PV panels, and it extracts the heat from the panels with water. And then we collect that water and store it in special thermal tanks so that we can use the water later. Well, what we found is while we maybe are saving 12 to 18% of that loss every day, we're also producing enough heat to double the energy output per square foot of a PV panel. And that was a huge finding for us, especially in California, where the full electrification movement is well underway. And this will help us to reduce carbon emissions through natural gas consumption for heating hot water and other things. We've been very fortunate to have a lot of support from the California Energy Commission, beginning with the CalSeed Concept Award, and then the CalSeed Prototype Award, and now Cal Testbed. And also, we're working hard on finalizing terms for the bridge program, GFO, with the state of California. We've also had a lot of help and support from NREL through the Shell Game Changer program, which we won in January of 2020 and is just wrapping up for us now. And then most recently here in October, we were selected for the Halliburton Labs scale-up program, which is tremendous because I'll be in Houston next week, and we're going to work with Halliburton for a year-long program to scale us up into commercial operation. We do have a couple of pilot projects going, in progress now, and that'll be wrapping up. We'll do our UL product certification on one of those. And we have several additional commercial projects lined up for next year and a big one for 2023. We're doing our Series A round next year. And right now we are scaling up our manufacturing for that particular panel that you're looking at. So it's been a great run. We're very eager to help. We feel we can have a massive impact on the carbon emissions and increase of energy output per square foot from PV thermal hybrid solutions. Thank you for inviting us today.
Hey everyone, I'm Dennis Nickerson, founder and CEO of Portable Solar, and developing a different way of holding a solar panel in place, a mounting system that consists of two hollow chassis made of recycled polymers that securely hold opposite ends of a panel, form a tilt angle, and can be filled with water or sand as ballast to provide stability against hurricane force winds. Our mounting system is placed on the ground, and we've designed it simply enough so that literally anyone can assemble a 2 to 3 kilowatt system in about an hour, fill it with ballast, and call an electrician to connect it to the house electrical system. We ship everything to the doorstep, our patent pending mounting system, panels, inverters, cables. And because there's no installation company involved, we project installed cost per watt to be about half the US rooftop average for equivalently sized systems. But we don't actually expect them to be equivalently sized. In fact, we expect most of our customers to be in the 2 to 3 kilowatt range, whereas the US rooftop average is closer to about 7. So that means that we'll be offering complete home solar systems priced at around 1/4 the US rooftop average, or roughly $5,000 versus $20,000. Now, $5,000 rooftop PV jobs are quite rare. So we don't think we'll be stealing share from installers, but actually making the pie bigger and attracting renewable energy advocates from households that until now had been priced out of the market. We have other use cases that we're exploring by eliminating a big chunk of the soft costs. Most of the investment shifts over to the hardware side, which in our case can be moved fairly quickly and cheaply. So we see possibilities with organizations like CAL FIRE, FEMA, but also in community solar and agricultural solar, where it may not always be possible or desirable to take title to a piece of land or to make a 25-year commitment to it. Whereas with our approach, since we have much shorter payback periods, a 5 or 10-year investment horizon could become realistic. Another channel that we're exploring is the corporate route. At $5,000, solar might be low enough to be considered as part of an employee benefits package. Not that the employer would necessarily fund 100% of the cost, but there are benefits for the employer to be involved. One being able to combine the investment tax credit plus bonus depreciation would allow the corporation to reduce its cost basis in the asset by about 60% in year one. Another benefit would be that any investment they make towards, call it employee solar, would likely count towards their corporate carbon goals, and do so in a way that I would argue would be more tangible and more visible than by purchasing carbon offsets in the financial markets. So if anyone out there is in corporate sustainability or HR, I'd love to discuss it further with you. Right now, we're at a TRL 5 with an initial prototype, and given the fact that all of the components that we use, except our proprietary mounting system, will be purchased off the shelf from tier 1 manufacturers, we think we can move quickly to UL certification and onto commercialization within about 12 months. We have a team of solar industry veterans combined with experts in thermoplastic design and manufacturing. And with our Cal Testbed Award, we'll be working with UCLA's Smart Grid Energy Research Center on stress testing our prototype. Please reach out to me at dennis@portablesolar.io. Thank you.
Thanks, all. Got ahead of myself a little earlier and wanted to get on stage sooner. So we'll have everyone join us and then we'll get started. So to give us a little bit of context, so before we get into the actual discussion, kind of just wanted to reflect on how much progress we've made. So as we know, this panel is having a conversation around how all of you are helping us achieve our clean energy goals, but it's also great to reflect on how far we've come and also know the differences, I think, than even like 10 years ago. So as we've seen in California, we've been really successful at getting solar onto the grid, especially, and what we're now starting to see is like the need for greater diversity of resources, which I'm really excited to dig into a little bit more, but then also how do we utilize our solar resources in a more efficient manner, maximize their production. So there's the issue of diversity and the need to change the resources or change the way that they have been performing on our grid. But then now we have this other issue of climate change. We've been talking about it for decades, and now it is really here in terms of how we're seeing it day to day. And as we're all very aware, these last 2 years have been even more vulnerable in that respect when it comes to our energy grid and its infrastructure. So, you know, I'm really glad and very hopeful about our future because there has been so much more collaboration in this space. And there's not only a discussion of how do we transition our grid to a zero carbon grid, but also how do we make it more resilient? And what does it actually mean to operate a system these days? And what will it mean, you know, decades down? And within that conversation, there's also the opportunity to bring in equity. So, you know, who are those that are most vulnerable and how are we getting those resources into their communities or having their voice at the table? So anyways, I'm very excited to dig into this a little bit further, but following your presentations, I did, you all spoke about the issue that you identified and how you're solving for it. But can you speak a little bit more, give us more context around how you came across the barrier and how you think your solution is helping us achieve that greater next level of a zero carbon grid? And I'll start us off with Mark.
Oh, sure. Hi. It's interesting that you brought that up, because one of the things that we've been able to achieve, or the reason we've been able to achieve these things, is because of new materials and new technologies that didn't even exist 10 years ago. For example, we use nanotechnology to improve heat transfer in a couple of different ways, a surface coating, and also we're exploring the use of nanotubes to improve heat transfer in a very thin layer of plastic, but otherwise be an insulator, which we don't want. 3D printing has enabled us to do things today, to test prototypes, to experiment with simulations that we've been able to do electronically, but now we can 3D print them at a very low cost, having to have each prototype manufactured for $10,000 or $12,000 a piece, and we 3D print for a tenth of that and can test. And we've been able to make a lot of progress that way. There's new fluids that we use today also that didn't exist. They're very low global warming footprint fluids with very good characteristics, and those are just some of there's at least a half a dozen things that we are doing today that didn't exist 10 years ago that enable us to do this. And many tried to do these sort of hybrid technologies like PV thermal since the 70s, but not very many of them survived. Some in the pool industry, the swimming, that sort of area, small residential, but nothing on a big commercial scale. And I think that's the reason, is because of that. And so this is enabling us to now have a huge impact on the output per square foot of the amount of energy that a typical solar panel, can create in that same square footage.
It's really exciting when we talk about things that we didn't even know were possible before, and it's because it really brings to the imagination like what will be in our future and what's possible there. I'll give it over to you, Dennis.
Okay, so going back to the question then about how you kind of came to the solution, right? I guess in my case, it was as kind of a frustrated homeowner and wanting to kind of do the right thing and install solar photovoltaic on the rooftop. And I did get some quotes, 10, 15 years ago, when it was financially untenable in terms of paybacks. And then, 3 years or so ago, I had kind of other series of quotes after reading the press about the substantial reductions in solar panel costs, right? 80% plus over the last decade or so. And yet the paybacks didn't really they didn't jump down proportionately from what I was expecting. And in my case, living in South Florida, it was still kind of, a double-digit number of years payback, 12 or something like that. So I just kind of really started digging into the numbers and trying to understand what the economics were from the residential solar point of view for the industry, and kind of came across this soft cost issue and the fact that the hardware had become, relatively cheap, and actually maybe 30 to 35% of the total cost. And really 2/3 or so was more about the soft costs. And so, the more I looked at the problem, the more I realized that the key for making this more broadly accessible on a behind the meter generation basis, right? I'm not talking about utility scale, but on a behind the meter basis, to make it more accessible, you kind of had to avoid some of the issues associated with the roof, and had to maybe think about it delivering those incremental watts to the household in a different way, in a way that was less labor intensive. And so that's kind of how we kind of eventually landed on this idea of what we call self-assembled solar. So kind of IKEA style, right? I mean, we ship a small kit to the house. It's designed so that you can assemble it fairly quickly. It's going to be a small system, right? It's not going to power 100% of your bill. But because you're doing part of it yourself, we're able to reduce the cost such that your paybacks are, you know, half or less than what they'd normally be for a rooftop system. So that's kind of how we got down that path.
It's really interesting. I love hearing about the personal story side too. I know that you mentioned, and we'll have some time to talk about a little bit more about incorporating the technology within potentially, you know, the corporate side sustainability aspect. But are you also envisioning using your product potentially with partnering with local governments? You know, there has been more experiencing with extreme hot weather. Is that an area that you've been exploring as well?
Yes, and would love to do more in California for sure. Yeah.
Great. Benjamin, what about you?
Yeah, so how I came to the solution? Well, I didn't, to be honest. The first folks to cover and power canals were in India. And that was in 2014. I read about it in a, one of these sustainable publications. And at the time, living in Arizona, previous to that, living in Los Angeles, and knowing what challenges we have of moving water through irrigation canals from the Colorado River to Las Vegas, to San Diego, to Phoenix and Tucson, and for Arizona specifically, and also to San Diego. Those are insanely huge energy hogs, pumping rivers uphill through scorching hot desert with sand dunes. I mean, who thinks of this stuff, right? But that's the scale of the problem at the time with water, that had acts of Congress to make these canals. And now we're dealing with climate change, these canals largely being powered by coal, nuclear, and natural gas, all of which use immense amounts of water. And so there's a cyclical waste cycle here that I think it isn't unique to the US, but is definitely a big problem that we need to solve. And when we have tier 1 cuts on the Colorado River, I think it's all the more urgent for all the states in the region to work together. So really, there's nothing scientifically difficult or experimental about covering and powering solar panels with energy. The fact that solar panels are so cheap really speaks to NRELs and DOEs and all of these scientists like those here on this panel that have worked so hard to make that happen. For us, it's a techno-economic challenge and a regulatory challenge. Getting the DOE to work with reclamation and allowing stuff like this to happen is one of the biggest hurdles. And getting folks like Jigar Shah to make ways of having these first pilot and even after pilot programs be fundable, because there is some risk there. And that's really the big challenge. And I think once we get past that, I think deployment of these systems is going to be huge, in the same way that you see parking lot solar and rooftop solar and utility land-based solar is already huge. Only, for us, it breaks my heart to see Joshua trees getting bulldozed, tortoises being displaced, dust storms, and all of these effects similar to urban sprawl happening as we're trying to go towards cleaner energy. I mean, it's like the same problems that we've caused in the past that we're trying to solve now with climate change, right? So, if we can really limit the amount of negative negative impacts that we have, I think on a regulatory standpoint and a policy standpoint, we really need to take a serious look at that. So not causing more problems than we're solving. But that's kind of like my stance on this whole thing. It's not really a technical one per se.
Yeah. Mark, did you have something to add on there?
I guess I didn't answer the first part of your question, which was how I came about it, or we did. And I had always wanted to cool solar panels because of the heat degradation, and just had an opportunity in life to begin working on that and did. So that's how that came about.
Great, thanks. What about you, Bjorn?
Well, we focus on the subsurface imaging and monitoring business. And my background, I did my PhD at Berkeley on monitoring nuclear waste, continued to oil and gas, and then got interested in the clean energy business. And in particular, as I said before, in the geothermal fields. And to be efficient, to develop really brand new technology using very exotic materials deployed in high temperature environments, we found that we had to build our own manufacturing facility, it was a tough haul for a small company, but we have now a state-of-the-art metal manufacturing facility. We have the state-of-the-art optical manufacturing facility, and I think that allows us to go from design or from invention to design to prototyping very quickly. And I think that's key part of, being a small company. You have to move fast in order to be effective. We do 3D printing of some of our prototype. I think it was Mark who mentioned that. One of our, and I'm sure that I'm speaking to all small companies now, financing is a big issue.
Every day.
Every day, yeah, exactly. So the most significant barrier I found is we are a small company in the field of giants. We Schlumberger is a subsurface company, and they get their a lot of applications because they're well known and they get deployed a lot by DOE. So we have been pushing so push from DOE, California Energy Commission, Department of Transportation, all three organizations we work with. It's critical not just to finance the invention and prototyping, but go through the whole process and implement it so we can get data to show the customers. That data for us, we as a sensor company, to show that we can measure fluid flow in the subsurface has been absolutely revolutionary, working with Battelle and DOE on that project. And DOE now has a technology implementation program. And I think we heard about that from the keynote speaker. And we actually started to talk with our project managers. His name is Bill Fincham. I give a lot of credit to Bill because he's been out there in the breach with us, pushing our technologies, that we need to have the implementation step as well. Because if you don't have the implementation, you have this wonderful functional sensor and a shiny object, but it's the data which makes the difference. We don't produce energy, we make producing energy cheaper and better and more efficient and more environmentally prudent. So there certainly have been a lot of challenges, but there have also been a lot of fun developments and a very rewarding process in my opinion.
Speaking about fun developments, you did speak about your excitement around the market activity for geothermal in California. What's currently one thing that you're monitoring or involved with that you're excited about in that respect?
Yeah, we actually gave a joint talk with the Consolidated Resources, who is now drilling a well and intend to co-produce geothermal energy and lithium in the Salton Sea. So and that's where one of the things I actually had in mind, the implementation of we actually got funded by CalSeed for developing an all optical pressure sensor work, and that was That was we got the letter of recommendation from the Consolidated Energy. Forgot the exact name of it, but it's an Australian company operating in Salton Sea. Those letters of support, but also the financial support to take a brand new tool, putting into a very expensive well. It's makes a lot of people scared. Is a critical step to really get market access and market penetration for new technologies.
Very, very exciting to see all the activity going on there.
Yeah, it's absolutely. And
Yeah.
but just one more point. If you're looking at the potential of geothermal energy, if you're looking at the total electric power produced in the United States today, geothermal has the potential to produce twice that. So we can go geothermal all the way and run our country on this extraordinary green energy. But geothermal has been kind of the ugly duckling in the green energy fields, unfortunately, but it will take significant investment because it's very difficult and very expensive to drill a geothermal well.
Well, now it's time to shine.
Right, right.
Bjorn, isn't Costa Rica totally powered by geothermal?
It wouldn't surprise me because they are a high temperature area, but I don't know that. But good for them.
Yeah, it's a good amount of geothermal, and I believe a large portion of hydro, since they do get a lot of rainfall there. Yeah.
Mate, I wanted to add one thing if I could. I just wanted to give a shout out to Jason Anderson and Marty Turek and Zach and the people at Clean Tech San Diego who've really been a big help to us. They, even before we got involved with CalSeed, those kind of programs are just so important to teams like all of our gentlemen would agree. You know, we're out there trying to do something on our own, and, you know, finances are always low, and you get support or introductions by these teams that are invaluable. And, you know, that's how we got then into CalSeed, and CalSeed did the same thing and helped us get to Shell through the Game Changer and then through Halliburton. I mean, it's just, you know, those networks that you guys create, Lacey and Clean Tech San Diego and New Energy Nexus, are just really invaluable to us little guys.
Yeah, no, that's right. I mean, actually, I gave a talk to Clean Tech Energy in San Diego a year ago, and together we consolidated the energy of geothermal energy, and you know that you have to go out and talk about the technologies and make them known, and that's a never-ending process.
Right. Now that's great. One, appreciate the feedback and completely agree that folks over in Clean Tech San Diego, Zach, Marty are doing a great job over there.
Right.
Benjamin, going back to you, I'm curious if through Cal Testbed you've been paired up with UC Merced. As I came across your company, I immediately thought of their report earlier. I think it was this year that came out that did show the amount of benefits that California could have with your type of technology.
Yeah, when we applied for Cal Testbed, we had already been on this topic. I had been on it since 2015, kind of in a black box and at U of A in Tucson, and already had a dialogue with Reclamation and so on. And so we were in a phase 1 SBIR with Department of Energy when that paper from UC Merced came out. And it was actually shockingly similar to what we were doing by comparing different structure types and so on and so forth. But we also had some very complementary data sources. Were more concentrated to the east of the Sierras. They're more concentrated to the west of the Sierras. So there's that. So I immediately reached out to Brandy and Roger Bales and say, here's our GIS stuff, for our canal systems, and which they didn't have, and kind of started a dialogue there, just a friendly research-based dialogue. So that's kind of the start of this. Is, you know, it's a really big push for something like this. Is we have to make the market. There is no market yet for this. So first we have to make the market, gather interest, and then maybe later we'll, you know, there'll be different companies competing, but we're not even at that stage yet. So anyways, we applied for CalTestBed, got it, and there were a list of labs that you could work from. Like, well, obviously I want to work with UC Merced, and pick them, and oh, there we go. So yeah, so Sarah Kurtz is actually the PI on that, and I think Brandy McEwen is going to be on our team as well too. So yeah, and they're really going to be testing our prototype, our phase 2 prototype, and you know, basically seeing, okay, does it perform in the same ways that their paper had said it might? And we're going to be testing different variables of water evaporation and panel performance and so on. And Sarah Kurtz, who's been with NREL for a long time, it's just an incredible researcher, is going to be leading that. And really, you know, we'll see how the lab tests turn out, but you know, fingers crossed, and really looking forward to that. So
great to hear. It's like the success of what CalTestBed can do, even just this phase of testing it out and actually putting it into action. So I'm looking forward to following your development and seeing how that goes. Coming back to you, Dennis, I was really intrigued with this concept of partnering with corporations, companies, and offering your product as a service to employees, as well as ways that the companies can meet their zero carbon goals. Can you discuss more if you've been like having those conversations with companies, if there's any partnerships currently in place or partnerships that you're looking for?
Well, so it's kind of hot off the press, Maite. So I literally just started reaching out to some sustainability folks, especially in the Bay Area too, where I thought they might be kind of more receptive than other parts of the country to an idea like this. But it's at the idea stage. You know, they're large companies, right? And then it kind of touches different parts of the organization. So it touches HR, right? And it's not a trivial task to mess with a company's, you know, HR package, employee benefits package, right? There's the sustainability folks, and then there's the finance folks, right? So it touches the organization at different points. So this is going to be a challenge organizationally to get across. But at this point, it's just an idea. The initial numbers seem to be fairly compelling, right? And you know, because of the combination of the accelerated depreciation plus the ITC, right? Plus, I think perceptually, it seems more, like I was saying, visible and more tangible for a company to be seen as meeting or exceeding its zero carbon goals in their own ecosystem, within their own employee base, in their own community, than doing a financial markets transaction, or especially with some faraway polluter, you know, some counterparty, right? Well, in this case, the counterparty are your own staff, your own employees. And so I think it has a number of things going forward for it. But like I said, it's super early. I would love to get, you know, feedback from folks here on the call and potential leads for sure.
If there's anywhere to announce something, this is definitely the place. So feel free to reach out to Dennis if you know of anyone, or if you're interested yourself. This is a great opportunity for that. And Dennis, those are really great points. I like the idea of bringing it home. You know, when we had discussions around diversity, you know, we often spoke about other ways that you were diversifying or impacting the communities around you, but it really starts also within our own teams. So very similarly here, how can we bring these direct benefits and directly to the employees and personalize it? Because especially as we do more, and we need to do more in this clean energy transition, we really need to personalize things. So that just goes back to how do we shift our cultures. And anyways, I'm very excited about the idea and potentially having that as a benefit in my future. I did want to take a moment because we've had more questions than usual. So I do want to give the opportunity to incorporate some things from the audience. So Dennis, just to follow up with you, we had a question from Marty, who is asking, what is your target residential customer price for your standard 3 kilowatt portable solar panel?
Okay. So I'm kind of the hardware piece, right? That's what I provide. And on the end user, call it, the resident, could be a homeowner, could be a renter, frankly, could be a renter of a single family home. Because it's not permanently affixed to the house. They're going to have their connection charges for, the electrician, basically. So we're looking at all in, and again, that electrician piece is going to vary throughout the country. So, but figure all in about $2 a watt installed before any incentives on the part of the customer. Now that compares with, and the reason why we kind of say, self-assembled solar for half the cost, that kind of compares with the work that Lawrence Berkeley Lab has done in looking at smaller PV systems. Well, they've actually segmented the market by size. And they've come up with a number of about $450 to $460 a watt for systems that are, say, from 1 to 3 kilowatts in size. Our own customer discovery interviews indicate that it's closer to $5 a watt, but we're comfortable saying that that we're less than half the typical cost for an equivalently sized rooftop system.
Thanks, Dennis. So knowing that we do have this platform, I did want to ask if there is one thing that you would want to highlight that could be improved upon, whether that's at the local levels with some barrier that you've been experiencing, or state and or federal, or if there's something specifically coming down the pipeline from the federal government. We've had the infrastructure bill pass that you'd like to highlight. So just want to give that call to action in terms of, what if something's going on locally or at state that could be improved or just worked on.
I guess we're actually working on a first pilot project, and the federal government's like, okay, awesome, let's do this, and then at the same exact time, but you need an environmental impact report for trenching something that's 20 feet long, and that's a year delay. So it's like, are you serious? What's that about? So really, I think there needs to be a lot of work put into streamlining and making sure that there's not these delays that are caused by the same entity that's actively trying to promote certain systems, clean energy systems. So things like environmental impact reports, regulatory hurdles, funding hurdles, so on and so forth. So those things really need to be streamlined. And I think right now, talking with solar developers, there's like a 4-year waiting list with Casio for utility scale projects. And I mean, I don't know how that meshes with with the goals that Newsom has, but there appears to be a direct conflict there. So I think really increasing the funding for those institutions with the specific goal of reducing the impact to the projects that they're actively trying to promote, I think would be the number one thing. And then number two would be, talking back with Jigar Shah and saying how can funding be loosened up for post-pilot, actually pilot and post-pilot projects that are still a little bit risky, too risky for a bank, but too small for DOE lending office, right? So how do we kind of get into that zone and make that freer? That's my 2 cents.
It's great to hear your 2 cents. I think, the point of having these types of platforms is to have dialogue discussions around where we can do things differently or potentially see opportunities. And I know that's specifically what you just referenced on the financing side too, is top of line and top of priority for the government, even at the state level. I know that there's been discussions going on there, but I'll pass it over to you, Mark.
I'm sorry, I was answering someone's question about what are we passing to me?
I was just asking, like, if there was one thing that you wanted to highlight, whether it was at the local or state level that could be an opportunity or barrier that you've been facing that could be alleviated in some manner.
Well, obviously, the biggest barrier that we've always faced is finance or funding, but that's not necessarily a state or government issue. Both of them have helped us in that regard through, especially the state of California, through California Energy Commission. Regulatory wise, though, not for us. I mean, not yet anyways. We have to do our UL certification coming up, and I think that we're going to face some issues there. It rains on your house every so often, but people still have this misconception about water and, on your roof. Like if you're doing something with water on the roof, it doesn't belong there, but it falls out of the sky on the roof too. So I'm not sure why that's an issue, but it is an issue for people. And so we have to alleviate that concern, not just with the UL, but we have to make sure that, our customer is not the residential home, it's really the commercial building, but still you have to make sure that no one is concerned that we're going to mix water and electricity and burn down their building or something.
Reflections that aren't necessarily intuitive. Thanks for sharing.
Yeah.
But Yarn, what about you?
Well, I take the opportunity to give a shout out to California Energy Commission. They actually funded an installation of ours into a gas storage field operated by PG&E up in McDonald Island. We installed the system in July, started operated in September, and one of the highlights, for me as a seismologist, we recorded the San Ramon 3.9 earthquake in real time and had the data processed. We saw the whole wave field coming in, but we also see, the events from the gas storage field, which is it's too early to kind of go into the technical details, but I'm very excited about what we see and that we can monitor that. And I think it's a gigantic industry, but again, it was funded by California Commission. It was PG&E was very cooperative in designing it, installing it, and PUC, Public Utility Commission, was also involved because they have to approve everything that goes into boreholes. So working with this, the funding, the operator, and the legislation or the state authorities made it work. And of course, we have in our company a terrific team, but it all comes together. But you have to sort of push this thing hard and make sure it works. The borehole environment, so it's a very unforgiving environment. So make sure that the designs are correct. We design things to 400 Fahrenheit, 500 Fahrenheit, and 20,000 psi. I mean, it's yeah. So it's wow. But yeah, that's one, I think, very good example of what cooperation between all the parties can generate. And we're hiring people. We're hiring engineers to help us make this more efficient and grow the company. And we are in San Fernando Valley, which is actually one of the manufacturing centers in the United States. It's not very well known, but Los Angeles is, I think, the largest manufacturing center in the United States.
That's fantastic to hear, Bjorn. And I know that there's been significant amount of investment, excuse me, from the state level around, things like what appears to be your projects and more on the R&D side. So it's just really great to hear an example being highlighted here today. So with that, I know that we are at time right now, but Dennis, I did want to give you the opportunity to wrap us up. And if anyone else would like to note anything before we transfer it back to Tenley.
Thanks, Maite. No, I just wanted to add, I looked at the clean energy section of the proposed legislation in Washington. There's some really exciting stuff in there. And who knows what percentage of it will actually survive, right? But I would just, make a pitch that that going forward, the investment tax credit you don't have to have a federal tax liability to be able to benefit from it. And hopefully that'll be one of the pieces. Hopefully be more pieces that will survive. But that's the key, because we need to do a better job in making residential solar more affordable for low and moderate income folks.
Yeah.
And that actually brought to mind the topic of microgrids and, how we've had some version of microgrids exist for periods of time, but the necessity now that we're seeing in having greater sectionalizing of the grid. And I know that there was a question earlier around if someone could speak to the innovation of microgrid solutions that would support the diversity of renewable energy resources. So Benjamin, I saw that you had an opportunity to respond there, but just wanted to give the opportunity for you to speak a little bit about what you touched upon there.
Oh yeah, actually, when you mentioned microgrids in this context with Dennis, I immediately thought of tribal nations who have sovereignty issues. They don't have a lot of money, and they're far away from the grid. And I think Dennis's product is perfect for tribes. Anyway, so yeah, and my answer to the microgrid is, when you can put energy user like a canal lift pump or an agricultural diesel pump or something like that right next to your power generation source, so solar panels over an irrigation canal, you have the opportunity for a small microgrid that is in a very remote region, agricultural region. And you can even pair that with stored hydropower. You can pump that water into a reservoir or a tank at night or during the day, and then release that water into a lower reservoir and back into the canal at night and get that energy back. And that right there is a small microgrid, or could be. That can also then power a small agricultural town or something else.
Really reimagining the way we build our communities. So it's very, very exciting. So with that, I'll end here and just note that I'm looking forward to seeing, what comes from your partnerships and your award with Cal Test Bed. And thank you for joining us today.
Thank you so much.
Thank you.
It was a great opportunity. Thanks.
Yeah.
Yep.
Thank you.
And thank you, gentlemen, for your really great discussion and talking about your innovations. And we're really excited to be working with you in the next year as you go to your Cal Test Bed facilities at the University of California facilities and at Lawrence Berkeley National Lab. We're just so delighted to be working with you. And now I would like to ask you all to join me on a virtual tour of UC Berkeley and the facilities that we're working with there.